So hello, so today I'm going to make a video on about part and property of the Abaqus CAE. So first of all, when we start the Abaqus CAE, what we need to do is select the work directory, set work directory, otherwise it will save all the data in the temp folder. So what you need to do is choose your own directory where you want to save your data, otherwise it will go to its default. So let's make a new directory. Set OK. Now everything will save here. So this one here is your uh, tree. This is called model tree, and shorter version of this is here. So first we will see part. This is part manager, and this will directly open the create part section. You can also select it, open it by this create section part. So in below, create solid extrude and cell extrude and all these things. Here it is for creating partition in the solid geometry. So first we will create. So what are the parts of this part section? First one is modeling space is in either 3D, 2D or axisymmetric. So first we will see 3D, and types are deformable, discrete rigid, analytical rigid and Eulerian. So if you are creating any part, it will be a deformable part. For example, if you are trying to simulate impact test, so the object will be deformable, and if hammer will be a discrete rigid part and analytical rigid. So this they will be rigid part where we don't need to focus our attention. We will focus our attention on deformable part. So what is the base feature? Solid, deformable. And what is the method of making? By extrusion, revolution or sweep. If you are creating discrete rigid, it will already make it as a cell, wire or point. So let's first create a solid with the help of revolution. Revolve it by 360 degree or 270 or whatever you want. So this will give you a cylindrical. This point here you can move, rotate. There are axes. You can watch any plane of the coordinates. Again, there are 2D. When we are if an object has symmetry, then we can make a 2D. For example, if we are working on sheet material or any kind of test that we can reduce to 2 dimensions, then it will make calculation easier and way much faster than the 3D section. So if you can reduce your calculation to the 2D objects, then go for it. For example, if you have a rectangular bar of tensile test, then you can create it as a 2D planar. And if you have a cylindrical bar, then you can go for axisymmetry. So whatever calculation we will get with this 3 dimensional, we will get it by axisymmetric also. Axisymmetric will be very much faster than the 3D, because the elements in the 3D section will be more and axisymmetric will be very less. What it does, it revolves every element and extrapolate all the results. Here are your drawing tools. You can create a line section, and this is dimension tool. So you can type the dimensions. This is your circle tool, and you can also give dimension in radius. There is no unit in the abacus, so first you need to know the what are the homogeneous way of representing every data, such as if you are putting values of stress, force, and all that units must be in homogeneous form. You can check internet for this. What is the homogeneous unit system for the abacus? This is your rectangle, and similarly there are curves and all that section. This is here for auto trim. As you can see, it will trim out this section. It is a very useful tool. You can move. This is for translate, mean translation of the object. This is for rotation, scaling, and mirror. So how to rotate? Let's say we need to move the object. Select the entity and say done. You have selected, say, this point, and you need to make it to 0 comma 0 or origin. Either you can type or direct select this via cursor. So this has translated. Similarly, you can rotate. Let's say copy. This is your point and 45-degree of rotation. And similarly, you can mirror the object. Let's say we need to copy. Then it says pick a mirror line, and it will make it a mirror. And there is your array, linear pattern tool. You can make different arrays of, let's say, there is your rectangle, and you need to create an array. As you can see, spacing between them, you can change it by here. One is for horizontal and one is for vertical. Okay, these are the tool I have used mostly. So now let's move on to the next section. Let's say we are creating an axisymmetric. Continue. Let's say this is your object. Now next is go to the once you have created the part, then there is property. This is create material, and this is material manager. So opening create will open the same page. So here is your materials. Make name whatever you want. Let's say steel. General density. If you are doing Abaqus standard, then no need of density. If you are doing explicit analysis, then density is required. So let's say density 7.8 E minus 9. So here you need to see what I have. 7.8 E minus 9. It is in uh, what I have said in homogeneous units. So you need to check how we put our units here. This is Young's modulus to 200 gigapascals. So 200 and 000, and this is Poisson's ratio 0.3. Plasticity, let's say 510 megapascals, and plastic strain will be initial plastic strain will be 0, and you can further add more data. So this is your elastoplastic. If you are doing an elastoplastic analysis, then this data will be required. If you are doing only elastic analysis, then elastic data is sufficient. If you are going to make a material deformation, if your deformation are larger, then it will go to the elastoplastic region. There are also some damage mechanics you can also add. I mostly use porous plasticity model. There are also other ductile damage model and Johnson Cook damage. You can also check based on your requirement. There is also deformation plasticity. Uh, then there is more Coulomb plasticity, and there are thermal properties, are also electrical magnetic properties. So here I'm going to do a mechanical analysis of tensile test or something like that. So I don't need any thermal or any other properties. So let's put it okay. So what you have done here, you have created a material named as steel. This is section. This is section manager. If you have multiple sections, then it may come in handy. So solid and homogeneous, say okay. This is plane stress strain thickness. If you are making it 2D planar, then it is very important to select this. In case of axisymmetric, no need, say okay. So what we have done here, we have created a section, and then we will assign it this section, and it will change its color. That means the section has been assigned a material of steel. So part has now properties of steel. So this is all. That's all. Here we have given property up to this section. Now assembly. Assembly is dependent or independent. Choose independent if you are making a geometry. If the part is meshed or exported from some other, then it will be a dependent. Otherwise, click it independent. Now what we have done here, created an assembly. So what are the parts? This is rotate, and this is translate. Let's translation in the radial direction is not supported for the axisymmetric instance. Since it is a axisymmetric analysis, we cannot translate other than this center line. So let's move it in the vertical direction. If you have created multiple parts and it is in 3D or 2D planar, you can make, you can create, you can pull out more. So there are two parts now. You can also rotate, and this is very important, merge or cut. So what we have here, merge geometry, mesh, or both. Click both, or either you can click geometry also. So once you have moved, click OK, otherwise it will disappear. So let's mesh this geometry, increasing on continue. What you need to do, select the and select instance to merge. Now what happened, it becomes one part. So if you want to create any partitions on that, you can select it from here. So this is all. That is how you can create parts and give properties and assembly. Thank you.